Okay, we've got another video for Algebra 2, and this is Section 5, and this is about rational equations, okay? So our objective is we want to solve rational equations and determine extraneous solutions, use rational equations to model and solve real-world problems. And so let's just go ahead and kind of talk about something here real quick. One of the things that we can do to solve rational equations is we can always, in order to take something from a rational equation to a non-rational equation. Okay, so this is a non-rational. Okay. We could, in order to go from this step to this step, okay, we multiply by the common denominator. Multiply by the greatest common denominator. Okay? Which is kind of a powerful thing to do. I don't always do it, but it kind of just depends on what you're given as far as the equation goes. So what I want to do, so a rational equation is an equation that contains one or more rational expressions, okay? And so you have this, rational equation down here. Now, what we want to do is we want to solve this equation for A, all right? So I'm going to zoom in on this. And what I want to do is identify what our common denominator is. So our greatest common denominator, so let me write that up here, our common denominator, okay, is going to be the product of this denominator, which is A and A plus 2. So our common denominator is going to be A times A plus 2, okay? And so what I'm going to do here is I'm going to multiply each of these terms by A times A plus 2, and we're going to see what happens. So watch what I do here. I'm going to take A times A plus 2, okay, and I'm going to multiply that by 15 over A, okay? And then plus, okay, I'm going to do the same thing. I'm going to multiply by A times A plus 2, and I'm going to multiply that by 9A minus 7 over A plus 2, okay? And then I'm going to do the exact same thing to this third one. I'm going to multiply A times A plus 2 by 9, okay? And so let's kind of see what happens here and see what divides out and what doesn't divide out. When I get this, when I'm doing this, all of these are over 1, okay? And this doesn't really need to be over 1, but we'll just do it there anyway. And so the reason why I do that is because whenever I multiply by the common denominator, I get this value, something will always divide out of my denominators in each of these problems. So what I can do, I can divide out the A divided by A, okay, and then I can divide out the A plus 2 and the A plus 2. So my next step of this equation is going to be the quantity A plus 2 times 15 plus A times 9A minus 7, and that's going to be equal to A times A plus 2 and then times 9, okay? So we have some distributing that we need to do, and that's okay, but let's just go ahead and go through that. Let's go ahead and distribute our 15 down here into each of these. So we end up getting 15A plus 30, okay? And then let's go ahead and distribute this A over here. So A times each of these. So I'm going to end up getting 9A squared and then minus 7A, okay? And then this is going to equal, let me go ahead and multiply this A through over here. And I can also multiply the 9 in. So I'm going to get 9A squared plus 18A, okay? Now, you're probably looking at this, and it's going to be a little bit tricky, but let's just go ahead and solve it. What we can do from this point is I can, let's combine our a squareds, all right? And let me subtract 9a squared from both sides. Okay, and what happens is that this adds to 0, and that this also adds to 0. So what's kind of cool about this is that each of these kind of cancel out, all right? And that's kind of nice. That kind of helps with our algebra. All right, so let's rewrite this then as 15a plus 30 minus 7a, and then this is equal to 18a. All right, so let me do this. Let me subtract, combine these like terms over here, 15a minus 7a. That's going to give me 8a. All right, so I've got 30 plus 8a is equal to 18a. And if I subtract an 8a from both sides, then this is going to give me 30 is equal to 10a. All right, and so if we divide by 10 on both sides and divide by 10, I end up getting that a is equal to 3. Okay, so I solved this equation. You know, I've kind of taken it from a, you know, from this problem that contained a lot of fractions down to something that did not contain any fractions, okay? And just a little bit of algebra and combining like terms. It was kind of a lot of steps, but, you know, we want to make sure that that works. Now, the other thing is we need to check our solution. Check to see if the solution is reasonable, all right? So check your solution. Now, what we want to do is we want to make sure that that when you plug in a equals 3, that it does not make the denominator 0. So make sure that the solution, okay, that the solution does not make the denominator 0. Okay, and in this case it doesn't. The denominator 0. All right, in this case it doesn't do that, but sometimes you might. Okay, sometimes you know when you do get you know like a squareds and x squareds and stuff like that, that you might have an issue where it actually does when you plug this in give you something that doesn't work out. So we always have to check that. Okay. All right, so let's go ahead and move on to the next problem and next page, and we'll see what we can do. Okay, let's go ahead and take a look at this next one, and this is kind of the one thing that we have to do is we have to factor a -1 in the denominator. Okay, and so the first thing I want to do is kind of think about what this part is here. Okay, what I notice is I have x plus 5 and I have 5 minus x as denominators. And then over here I have x squared minus 25. So watch what I do here. Okay, let me rewrite this as x over x plus 5 plus 5 over 5 minus x. And this is equal to x squared plus 25. Now the cool thing about my denominator here is that this factors. This is the difference of squares. So this is going to factor out to x plus 5 times x minus 5, okay? Now, the thing that we have to realize here is that 5 minus x and x minus 5 are not the same thing. They are very close, though, okay? And so let me write that over here, that x minus 5 is not equal to 5 minus x. Okay, those are two different things, okay? And how I know is that, my x here is positive, here my x is negative, here my 5 is negative, and here my 5 is positive. So these two things aren't equal. However, what I can do out of this is I could factor out a negative number here to turn it into x minus 5. So let's do that. Okay, so if I write this as x over x plus 5, and then plus 5 over, let me factor out a -1 out of my denominator, and that's going to give me a -5 plus x, okay? And if I redistribute that negative number, it'll turn me back up here. Okay, so I have -5 plus x, and let me make sure that this is x squared plus 25 over x plus 5 times x minus 5. All right, and so if I were to rewrite this now, okay, I can rewrite that piece as x minus 5. And let me do that all up over here. All right, so I get x over x plus 5. And then this negative 1 is in my denominator. And if I do 5 divided by negative 1, I can really turn this 5 into a negative. So when I factor out this negative 1, it makes this whole thing negative. So I can do a subtraction, okay, and I could subtract out 5 over x minus 5. And then that's going to be equal to x squared plus 25 divided by x plus 5 times x minus 5. Okay. Now my common denominator, okay, my common denominator is going to be x plus 5 times x minus 5. Okay. And so with that, what I want to do is I want to multiply every single one of these terms by my common denominator, which is x plus 5 times x minus 5. So watch what happens here. All right, so if I do x plus 5 times x minus 5, okay, do that over 1. And if I multiply that by x over x plus 5, okay, let me do that. And then let me do minus, and let me do x plus 5 times x minus 5, do all that over 1, and then multiply that by 5 over x minus 5. Okay, we got that. And then let's do the same thing for the last one. And this is going to be x squared plus 25 all over x plus 5 times x minus 5. And I want to multiply by my common denominator, which is x plus 5 times x minus 5. Okay, so now comes the fun part of dividing anything that you see out, okay? So what I see over here is I have a common x plus 5. We're multiplying everything, so I can divide those out. So this divides out, and then the x minus 5s divide out. And then on the other one, okay, the x plus 5 and x minus 5s all divide out. So I've got a all right, so now, okay, what I've got is I have, and let me zoom in, okay, so I've got an x minus 5 times x minus the quantity x plus 5 times 5, and then this is just equal to x squared plus 25, all right? So, you know, once you kind of, you know, I know it's a lot of steps, I know it's a lot of writing, but once you get rid of these things, it really doesn't become too hard of an issue. All right, so now let me distribute my x, and let me distribute my 5. So we end up getting x squared minus 5x, and then minus the quantity. This is where you're going to get screwed up, minus 5x plus 25, okay? And then this is equal to x squared plus 25. Okay, so at this point, we need to distribute a negative here. All right, so this is going to become x squared minus 5x minus 5x and then minus 25, and then this is going to equal x squared plus 25. Okay, now, if I combine my like terms, I'm going to subtract out an x squared from both sides. Okay, then these cancel out and go to 0. All right, and so then as a result, let me write this all up over here, running out of room. This is going to give me a negative 10x, okay, minus 25 is equal to positive 25, okay? Now, if I add 25 to both sides, all right, this is going to give me negative 10x is equal to 50, okay? And then if I divide by negative 10, divide by negative 10, all right, then I get that x is equal to negative 5, okay? Now, all right, so we've solved that, okay? Now, let's talk about what we call an extraneous solution, okay? So when we take our, our original equation, which is what we had, okay, and we turned it into some sort of derived equation, and we arrived at x equals -5. Well, what's the problem with that, okay? And there's an issue with this, okay? And the problem is if you take this and plug it into your original equation, okay, and let's just do that. Let's just plug it in -5 over -5 plus 5 plus 5 over 5 minus -5 is equal to -5 squared plus 25 over -5 squared minus 25. Okay. What happens is that this part here becomes 0, so you get -5 over 0, which doesn't work. And then this part also becomes 0. Okay, so where you end up getting the number 50 over 0. Okay, now what happens is, okay, this is an extraneous solution, okay, and that's a solution to an equation derived from an original equation that is not a solution to the original equation. Okay, so this is your solution, but it is an extraneous solution. So extraneous solution. And that means that it makes the denominator here in your original equation 0. It doesn't work. Okay, so you still get a solution here. It's just called extraneous. Okay, so that's what that means. All right, so now there's another way of kind of doing this, of solving these problems, and that's using the cross product property, which has become very, very handy to solving these problems. So to first talk about the cross product property, what I want to do is just kind of look at what it's saying. And what it's saying is that you have two fractions that are equal. And if you take this number a and multiply it by d, it is equivalent to taking b and multiplying it by c. So let's just quickly take a look at something, an example. Let's just take a look at, say, like 1/2. An equivalent fraction would be like something like 4/8, okay? And so if I took 2 times 4, okay, is that equal to 1 times 8, okay? And so you get 2 times 4 is 8, and that is also equal to 8, and that is a true statement, so this holds true. So if we have an equation with two fractions that are equivalent, we can do the same thing. We can multiply across, take 5 times -4, and then take x times x minus 9. So let's do 5 times -4, and then x times x minus 9, and we'll solve for x. So let's go ahead and take 5 times -4 gives us -20. And then let's distribute this x here, and so we get x squared minus 9x, okay? And what I have is a quadratic, okay, and we got to solve this. So I'm going to go ahead and just move this -20 over to the other side and set this whole thing equal to 0 and solve from there. And so what I want to look for is I want to look to see if I can factor this. And if I can't factor it, then I'll do the quadratic formula. But if I just take a look at this, two numbers that multiply to 20 but add to -9, and that's going to be -5 and -4. So then we get x minus 5 and then times x minus 4. So set x minus 5 equal to 0 and set x minus 4 equal to 0. So if I add a 5 to both sides, then I get that x is equal to 5, okay? And then if I add a 4 to both sides, then I get that x is equal to 4, okay? So those are my answers. Those are my solutions for this problem. Now we do need to check and make sure that 5 and 4 will work in this situation, okay? And, you know, we really kind of just want to look at our denominators and just make sure that there isn't a value for x that makes our denominator 0. Okay, so if I plug in 5 into this, okay, -4 over 5, that's fine. Okay, we'll be good with that. And even if I plug in, say, 4 over that, you know, we'll be fine. So, so that's that. All right. So I hope you guys enjoyed this video. I know it's kind of there's a lot of information, a lot of stuff, but you know, just verify use your steps to solve, but always kind of be aware of your solution and make sure that it works.